Hello and welcome back to AlgoTutor sorting series. I am Akshat Jain and I am a software development engineer. So in this lecture, I'm going to start with a new type of sorting, which is quick sort. Quick sort is very much similar to merge sort, as these both sorting algorithms are recursive, follow recursive approach and follow divide and conquer algorithm. Now, what is quick sort and why do we use quick sort if we have merge sort? So quick sort basically fix the element to its correct position. After that, the position that after that element, the left side of the elements are smaller than that, and the right side of the array is greater than that element. Let's take an example. I have an array, suppose 35, 50, 15, 25, 80, 20, 90, and 45. Suppose I have this array. Let's fix, we will be required 3 pointers here. Okay, let's suppose 35 is our pivot element. What is pivot element? Pivot element is that element we have to find its correct position of this element. Now we have to take 2 pointers more. First one will be, let's suppose P, or we can say it low, and let's take Q, or we can say it high. Now what is P? P is basically we have to find the element greater than the pivot element using the P pointer, and we have to find element smaller than the pivot element using Q pointer, which means after that, right side of the pivot is greater and left side of the pivot is smaller. Okay, so let's start with our first pass. What is pass? For pass is basically when our pivot element is fixed to its correct position, our first pass will end. Now let's move and find the greater element than pivot. Okay, is 50 greater than 35? Yes, it is. Okay, so we find the pth element. Now is 45 less than 35? No, it is not. Then decrement Q. Is 90 less than 35? No, it is not. Is 20 less than? Yes. So what we have to do, we simply have to, first step, if we find P and Q, what we have to do, we have to swap first P and Q. Okay, now let's swap P and Q. Here it will come 20 and here it will come 50. Now P is here and Q is here. Now again is now we'll increment P. P is here. Now is 15 greater than 35? It is not. Okay, it is not. Is 25 greater than? It is not. Okay. Is 80 greater than? Yes, 80 is greater than. Now we'll move P and Q simultaneously. Okay. Now is 80 less than 35? No. 25 less than 35? Yes. Now Q is here. If P and Q are crossed, if Q crossed P, what we have to do, we have to swap pivot element and qth element. We have to swap the pivot and Q. If P and Q are crossed, now let's swap them. It will come 25 over here and it will come 35 over here. Now remove Q, remove P, remove pivot over here. Now see, at 35, all the elements at the left are smaller and all the elements at the right are greater. So this means we have fixed 35 to its correct position. Now, at the beginning of the lecture, I have said that this followed divide and conquer algorithm. Now, follow the same approach for this part of subarray and for this part of subarray. Now, since this is fixed, now we will follow same approach for the left part of the array and the right part of the array. Now let's solve for the left part first. Okay, so again this will be our pivot. Okay, this will be our pivot, this will be Q and this will be P and Q. Okay, we'll find the greater element than 25. Since we didn't find any greater element, so it will move out of range. Okay, let's suppose P comes here. Now we'll find for the smaller element. Okay, so 15 is smaller, but P and Q are crossed. P and Q are crossed. So what we'll do, we'll swap Q and pivot. We'll swap Q and pivot. It will give me 15, 20 and 25. Now we can see that this part is also sorted. Now let's solve for the right subarray. This is our pivot. This is P and this is Q. Okay. Now let's see. Is 50 greater than 80? No, it is not. Okay, increment it. Is 90 greater than 50? Yes, it is. Is 45 less than 80? Yes, it is. So since both of them have not been crossed each other, so what we'll do, we'll just swap P and Q first. So it will give me 45 over here and 90 over here. Okay, 45 over here and 90 over here. Now again I'll look for greater element than 80. So I'll move forward. I'll got P over here, and smaller element than what? Smaller element than 80. So it is not. I will move Q over here. Okay, I will move Q over here. It is smaller. No, it is not smaller. I will move again Q over here. It is not. I will move again. P should be here. Okay, P should be. Okay, P and Q should be here. Okay, finally we'll got P and Q should be here. P and Q should be here. Now what we'll do, we'll just simply swap with our pivot element because they have crossed each other and then didn't find the greater element and the smaller element. I'll just simply swap both of these, which will give me 45, 50, 80 and 90. So we can see that left part 35 and the right part has been sorted using divide and conquer algorithm. The first step was, let's look back to the steps we have used. What the first step was, we have picked the first element as the pivot element. We have to find its correct position. So we have taken two variables P and Q. P is looking for the greater element than pivot element and Q is looking for the smaller element than the pivot element. After finding the correct position, we'll just swap pivot and Q with element. We'll find the correct position of the pivot element. After that, again follow that approach for left part and for right part. This states that this is going to follow a recursive approach. In the previous lecture in the merge sort, we have seen that using merge function and merge sort function, what merge function was doing and what merge sort function was doing. Okay, let's understand its code now. Oh, let's start with the main code. Suppose we are given an array with 7, 6, 10, 5, 9, 2, 1, 15 and 7, 8. Okay, we'll pass to it quick sort function first. Now let's understand what is quick sort function. I have taken array low and high. I have passed what? 0 and -1. Okay, I have taken low and high. Low is basically the 0th index and high is basically the last index. Okay, if low is less than high, it is checking the condition whether we are going in the correct direction. If it is, we'll find first the index. What is index? Index is the pivot index. Pivot index is basically this index. We are finding this index to follow left part and follow right part. Okay, so we'll find using the partition function, we'll partition the array into two parts, left part and right part. We'll pass array low and high. We'll look the partition function later. Now, after getting the index, I will again follow the same approach from passing low to index -1 till here. Because if it is low, then it is going to be index -1, and from index +1 to high. From index +1 to high. We'll follow the same approach for left part and for right part. Now let's understand what is partition function. Let's take the first element as pivot. As I've declared, we are taking the first element as pivot. You can take any element as pivot. You can take the middle element also, or you can take any randomized number also. Okay, let's take 2 pointers, low and high. 2 pointers, as I said, I want 2 pointers. Low will look for the greater element on the right, and high will to the smaller element to the left. Okay, low will move from right to left and high will move from left to right. From I equals to high to low, I minus, so high is moving to its left. If I find any element greater than pivot, what I will do, I'll just simply swap array of I with array of k minus. I'm just putting that element at the end. Okay. After that, I will just simply swap the element low and k because I have got the pivot element index. So we'll just simply swap to its correct position and I will return the k. What is k? K is basically the index of the pivot position. It will pass over here index and it will call left part first, then right part, and it will return me an sorted array. So I hope you have understood the working of quicksort algorithm. Now let's talk about the time complexity. So since it is recursively calling and dividing array into subparts, it is dividing array into first left part, then right, then left, and right. So basically it followed divide and conquer algorithm. And the time complexity of this approach, this sorting algorithm would come out to be big of n log n. So I hope you understood the quicksort algorithm. Please try this at home. Try taking more examples, try running this code once again, and I hope you will be able to understand and form the code by your own. So this was about this video. I hope you enjoyed this series. So we'll meet soon with great more series coming for you. Till then, bye bye, happy coding.